Welcome back. I want to talk now about how to solve a right triangle. So solving right triangles. And we're going to take some right triangle examples and we're going to take limited information and from that be able to figure out everything that's missing. So that when we're done we'll know all three angle measures and all three side lengths. And being able to do this will be helpful for some different application problems. There's all kinds of applications for this involving angles of elevation, angles of depression, bearings, measuring distances, and so forth. So we need to be able to solve the right triangles and then we'll be able to do some of these application problems. So first right triangle situation, let's say that this is right triangle ABC. Okay, and let's say that we're given that angle B is 28 degrees 40 minutes. Let's say we're also given that side A is 25.3 centimeters. So side A, when we're labeling these, if this is angle A, then right across from it we'll call side A. If this is angle B, right across from it we'll call side B. And if this is angle C, right across from it we'll call side C. Okay, so we know that side A is 25.3 centimeters. Okay, so from this, just this information, we're going to figure out all of the rest of the values here. We're going to figure out the other angle, and we're going to figure out sides B and C. Alright, let's tackle the angle first. Now, we know there's a right angle here, which tells us that angles A and B together must equal 90 degrees. So if we know B is 28 degrees 40 minutes, then to find A, angle A, we can say 90 degrees minus 28 degrees 40 minutes. Alright. Now we know that there's 60 degrees in a minute, so we can go ahead and change 90 degrees to 89 degrees and 60 minutes. And then we're subtracting 28 degrees 40 minutes. Okay, 60 minus 40 gives us 20 minutes, and 89 minus 28 gives us 61 degrees. Okay, so we know that angle A then is 61 degrees 20 minutes. Alright, now how do we tackle the sides? How do we figure those out? Well, we've got our trig ratios that we had at our fingertips that we can use. We know one of the sides, we know what the angle measures are, and we can use any of our trig ratios here to help us to find these. Let's say we take angle A. We know the opposite side. Well, if we do the sine of 61 degrees 20 minutes, sine is opposite over hypotenuse. So 25.3 centimeters over the hypotenuse C. And we can solve that for C. We can say, well, multiply both sides by C, divide both sides by sine, the sine there. And whatever that comes out to, put it in the calculator, whatever that comes out to, that'll give us the length of the hypotenuse. So let's see, let me pull up my calculator. 25.3 divided by, and just to be safe, well, I'll just say, okay, sine of 61. Go to my angle menu and choose degrees, and 20, and then go to my angle menu and choose minutes, and close that, hit enter, and see what I get. I get this crazy decimal, 28.8343, etc. Now when I was doing this problem, I had 25.3 centimeters, so I had like 3 significant digits there. So I'll go ahead and just round this to the 10th place and have 3 significant digits as well. So I'll just go ahead and say 28.8 centimeters for that. And since I'm rounding, I'll go and say that's approximately. This little squiggly equal sign means approximately, because it tells us we rounded or something. So that solves one of the sides right there. Oops. And we just have one more side to go. Now if you want to, you can use your trig ratios again, or since this is a right triangle, you can use your Pythagorean theorem. You can say, well, I know that b squared plus 25.3 squared has to equal that 28.8 whatever it was squared. So I could pull up my calculator again, and without erasing anything so far, I could square this result. I can go ahead and say x. I can just hit x squared. It'll take the previous answer and square it. And then I can subtract the 25.3 squared and then take the square root of that. Second square root of the answer, second answer down there. So hit second and then go down here to answer, and it'll take the square root of the previous answer if you use that key there. Enter, and there we go. So I basically went through, I squared the 28.83436023, that was this part, then subtracted the 25.3 squared, because I'm trying to solve for b squared, then b squared equals this value here, and then I took the square root. I know it's the length of just a regular old triangle, so I just need the positive square root. So I end up with, we can go ahead and round to 10th place, give it 3 significant digits, so 13.8. So B is about 13.8 centimeters. So now I have values for all 3 angles and all 3 sides. So we could say I've solved this right triangle. I've completed it. I've gone through and figured everything out about it. Alright, let's do another one. Let's go down here. I got a right triangle previously drawn. This triangle, we're going to solve it. It's another situation where you're missing some stuff. On this one, you're actually given no angles. Like previous example, we were given originally we were given we were given angle B's measure, and we were given side A's measure. So we're given an angle on the side. So you're finding the other angle is just a matter of subtracting from 90 degrees. But in this next situation, we're not going to know what any of the angle measures are. Let's see, we have angle A, and by the way, I've not drawn these to scale, so if the angles don't look like they're drawn at the right measure, sorry, alright, side C we're going to be given is 53.58 centimeters. And side A going to be given is 29.43 centimeters. And then we got to find side B. And we also have, we have to find all the angle, well, angle A and angle B. We already know C is a right angle. Okay, let's see here. We know, since we know side A and side C, we know side A and the hypotenuse. If we look at angle A, side A is the opposite side over hypotenuse C. That's the sine right there. That's set up to do sine. And we can use that to help us solve for angle A. Like sine of angle A equals opposite over hypotenuse. And we learned that, if we're trying to find the angle, we can use the inverse keys. We can take the inverse sine of 29.43 over 53.58. So let me pull up my calculator again. Move it over here. Okay, so if we do the inverse sine, that second sine of 29.43 divided by 53.58, enter, and there we go. We get 33.31709.144. So we could go ahead and say like 33.32 degrees or so. Because our numbers had 4 significant digits each, so we can go 4 significant digits here. Say 33.32 degrees. So angle A is about 33.32 degrees. But that's enough. That's enough to know for most purposes. And then to find B, just do 90 degrees minus A. 90 degrees minus the 33.32 degrees. Hang on a second, did I read that right? Yes. Yeah, 29.43 divided by 53.58. So yeah, we get 33.32 degrees. Well, then from there, subtract. Now we get angle B is around 56.68 degrees. Alright, and then last but not least, we need to find side B. But you know what? We can use Pythagorean theorem for that. A squared plus B squared equals C squared. 29.43 squared plus B squared equals 53.58 squared. So let me see, let me pull up my calculator again. I like doing this stuff in the calculator because then I just leave it all in there and not worry about rounding yet until I'm at the very end. It's good not to round things until the very end of your computations. So you got 53.58 squared minus 29.43 squared. The calculator will follow order of operations. Ooh, uh-oh. I accidentally ended up typing a second 3 in there. Okay. So 53.58 squared minus 29.43 squared. It'll follow order of operations, so it'll go ahead and do the squares before the subtraction. So you can hit enter, and that's what you get if you after you subtract this and subtract these twos. And then b squared equals that, so find the square root. So square root, second negative sign will give pull up that answer. And there you go. You get 44. You can go ahead and, since it's 4 significant digits in each of these numbers, we'll round to 2 places, 44.77. So B is around 44.77 centimeters. But now we've been able to solve this right triangle as well. We've started off just knowing 2 sides, and we were able to solve for the third side and the 2 angles. And it's all using trig ratios. I decided to use sine of A here. I think sine of A probably was your best bet, but you could have did cosine of B also, cosine of B, and you could have gotten the result and gotten B's angle that way. So there's other ways you could do this. The way I did is not the only way. And then from there, once you knew B, you could have subtracted that from 90 to get angle A. Okay, so that's how to solve a right triangle. Next, we're going to dive into some applications, but I'm going to save that for a separate recording. Thank you for joining us.